Okay, good morning, students. In yesterday's class, we have started learning about remote replication, how remote replication can be taken at a distant site or a distant data center, so that in case of a data center failure because of a disaster, then the information can be made available from the remote site at a distant location. Now we have seen the modes of remote replication as synchronous replication and asynchronous replication. So whenever the original copy is written by the application to the source disk, then immediately it will be written to the target disk also, where the replica is stored, and that acknowledgement received from the target by the source further acknowledges the application that the data is written. This is called as synchronous replication. Means the write activity or the write operation that is attempted by the application will not be completed until it receives acknowledgement both from the target disk where the replica is stored and the source disk where the original copy is stored. This is called as synchronous replication. Means this synchronous replication ensures that before any other write operations are executed, it ensures that the previous write operations are completely committed to the source disk as well as the target disk where the replica is taken. And this is the approach followed in synchronous replication. And we have also discussed about the bandwidth utilization, where the required bandwidth, when it reaches maximum because of synchronous replication, the amount of response time also keeps increasing as the write workload increases. And in the asynchronous replication, we understood that the write acknowledgement is directly given by the source itself. When a write attempt is made by the application host to the source, immediately the source will acknowledge that the write has been completed to the application host. Now, after that, the writes will be buffered on a buffer that is available on the source. And once the buffer is full, then at a time it will flush those modifications or the new write operations, these modifications saved on the buffer or the new write operations that have been performed against the source will be transported to the target at the remote site. Those changes will be reflected at the target, and target will acknowledge the source that the new updations have been completed. That is how the replica is modified in case of a write that happens at the source. This is called as asynchronous replication because immediately when the data is written to the source, it is not updated at the target also where the replica is stored. But it is buffered, and at frequent intervals of time, it will be sent to the target to take the replica. This is what is followed in asynchronous replication. But in this case, there is danger of losing this buffered data. Up to this buffer capacity, the data may be lost in case before flushing out the buffer data to the target target at the remote site. If the source fails, then up to that buffer data will be lost. So this kind of asynchronous replication will not promise near zero RPO. Near zero RPO means there is no risk of losing any data. That is called as near zero RPO. Near zero recovery point objective tells that no data will be lost even in case of a failure by any business. Okay, but limited RPO means limited recovery point objective means there we can't promise near zero RPOs. In such case, there is always some risk of losing the data. Now, in this case, there is risk of losing some amount of data, at least of the buffer size, which is maintained at the source before it is flushed to the target. That much amount of data may be lost if at all the source disk's data center fails. Okay, this is called as asynchronous replication. So synchronous replication will promise near zero RPO, whereas asynchronous replication will give us very limited RPO, very limited recovery point objective. Means there is danger of losing the data. So this is the bandwidth requirement, though the required bandwidth is maintained at an average, because every time the data is copied to the source, immediately it may not be copied to the target. So the bandwidth utilization will be at an average, but as you go on increasing the workload, still the response time also increases. Okay, that is shown on the x-axis. The response time is shown on x-axis. Now, as you go on increasing the write workloads, the amount of time that is required to get the right acknowledgement will keep on increasing, because the bandwidth utilization will be more, as it have to write to the source and then to the target at frequent intervals after buffering the updations at the source. Okay, this is called as asynchronous replication. Now let us move forward to see remote replication technologies. In yesterday's class itself, I have started this topic to see that there are three kinds of remote replication technologies, same as in local replication. They are host-based replication, storage array-based replication, and network-based replication. I'm repeating this again. Remote replication technologies and local replication technologies are very, very important. They may ask you both of them together in one question, or they may ask you to compare also how it works. Now, in both local replication and remote replication, you have three types of technologies that are followed, three types of implementations that are followed. The first one is host-based local replication or remote replication, storage array-based local replication or remote replication, and network-based local replication or remote replication. Now, when you take the replication activity to be executed by the host, means the application server, then it will be overburdened by the replication activities, because the host have to already serve the application requirements, application IO requests, and in addition to that, if the host is also overburdened with performing the replication activities, then the resource utilization will be very large on the host side, and the IO performance will be degraded, and the response time will be increased on the host side. Okay, so though there are some advantages with host-based remote replication, because you can do it at a centralized point at the host itself, and that will quickly perform the replication task. There are still some drawbacks like overutilization of resources, and at the same time degradation in the performance of the host. Right? These are the drawbacks. And also we have seen that there are two types of basic approaches to perform the host-based remote replication. One is by using the logical volume manager, and the other one is data replication via log shipping. Now in this logical volume manager, we, instead of calling the copies being stored on the source disk and the target disk, we call them as the original copy is being saved on the source volume and the target replica is saved on the target volume, because data is not directly stored on the physical disk, but due to the virtualization provided by the logical volume manager, here we say that the data is saved on logical volumes rather than physical disks. Okay, originally at the background they will be saved, data will be saved on physical disk, but the client seems to have a virtualization layer where it is set to store the data on a logical volume rather than a physical volume or physical disk. Okay, now in this case, we call the source where the original copy is saved as source volume, and we call the target where the replica is saved as the target volume. Instead of source disk and target disk, we call them as source volume and target volume. Now we have seen that in logical volume manager based remote replication, whenever a data has been, again under that we have two types, synchronous and asynchronous replications. Now in synchronous replication, again in LVM, whatever data is stored on the source volume will immediately be saved on the target volume also, and the acknowledgement is received. But when it is asynchronous replication, again, the data is buffered at the source volume, and at frequent intervals, it is flushed to the target volume where the replica is stored. And that transferring of data at frequent intervals. The buffer data, transferring of the buffer data from the production host to the remote host happens over IP network. Okay, so all these we have covered in the last class. Just to give you a quick recap, I have repeated that once again. And again, under host-based replication, we have log shipping also. What is this log shipping? You know that database is not stored on a single physical disk. It will be spanning multiple physical disks. In such cases, it will be hard to take the replica copy. In such cases, if any new transaction is performed, which would be a combination of multiple read-write operations. Now, all that set of operations under a single transaction have to be written to the remote site also. Now, when this operation is happening, all the activities under a transaction, read-write activities under a transaction should be executed. Rather than saying read, only write operations, because read operations doesn't make any changes to the source copy, so it need not be reflected on the replica also at the remote site. But if there are any write operations that are being performed as part of a transaction on the source volume, then that have to be reflected on the target volume also. Now, whenever a transaction is executed on the source volume side, which contains series of write operations, then the same sequence of write operations have to be executed on the target side also, in order to preserve the consistency of the data on the replica side, on the target volume, same as the source volume. For that, what they do, whenever some changes occur to the source database, those changes will be temporarily stored on a file called as log file. Now, at frequent intervals of time, this log file is shipped to the remote host over an IP network, where the log is replayed on each of the parts of this database, so that the changes made in the source database will be reflected on the standby database also at the remote site. This is called as host-based log shipping. Host will be responsible to maintain this log file and ship it at frequent intervals to the remote site, so that the standby database is also updated. Now remember, this database on the remote site will not be up and active all the time. It will be kept in a standby mode, where it will not be available for any of the business continuity hosts. Right? It will be just kept in a standby mode. Whenever a change occurs due to some transaction on the source side, that change will be reflected on the remote database at the target database. Only when the log is shipped and the log is replayed on the database, that new changes will be reflected on the remote site. Only during playing of this log file, only when replaying this log file against the databases at the remote site, that remote site will be up and active. Again, after that, it goes into standby mode, so that it will not consume more power. And at the same time, it will not be responsible for other business operations, other business continuity operations. Okay, this has to be presented under host-based log shipping. That has been explained in these slides. Now let us go to storage array-based remote replication. In storage array-based remote replication, the array operating environment and resources perform and manage the data replication. So in this case, you need not overburden the host CPUs. This relieves the burden on the host CPUs, which can be better used for serving only the application requirements. Host will generally be overburdened if you also add the replication activities to the host. But in storage-based remote replication, you will be freeing the host, application host, from this replication activities, and host server will be completely dedicated to serve only the application requirements. So in storage array-based remote replication, the array operating environment, it will have an operating system, it will have an operating environment, and resources perform, and it will also have some dedicated resources which perform and manage the data replication. Okay, so the resources that are allotted to the storage array and the operating system that is provided will actually be responsible to perform and manage the data replication on the storage array side. right? Now, a source and its replica device reside on different storage arrays. In local replication technology, I'm repeating this again and again. Remember, this is very important point. When storage array based replication is being done at the local level, means in storage array based local replication, the source disk and the target disk can be within the same storage array, or it can be in different storage arrays also, but within the same data center. But in this case, in storage array based remote replication, a source and its replica device reside on different storage arrays to indicate the basic idea of remote replication. And after that, they might be also on a different storage array in a different data center that is geographically apart. Right? So data can be transmitted from the source storage array to the target storage array over a shared or a dedicated network. So it can utilize a shared network or a dedicated network which is used only for performing the replication activities. Now, replication between arrays may be performed in synchronous, asynchronous, or disk-based, disk-buffered modes. So if when you're performing the replication activity on these storage arrays, it can be performed as a synchronous approach, asynchronous approach, or disk buffered modes. Now, what happens in synchronous replication mode? In array-based synchronous remote replication, writes must be committed to the source and the target prior to acknowledging write complete to the production host. This is what happened in the replication, initial concept. When we are going through the modes of remote replication, we have gone through two types, right? Two modes, synchronous replication and asynchronous replication. That is, synchronous replication always acknowledges the host about the write operation completion only after it is written to the source as well as the target disk. In this case, because it is using a remote mode, first the data will be written to the source volume or the source disk, then it is written to a target disk or target volume at a remote site, only then the acknowledgement will be given to the application host that the write operation is complete. Okay, now additional writes on that source can't occur until each preceding write has been completed and acknowledged. If any new writes are happening, then it will first ensure that the preceding writes have been completed and acknowledged by both the source and the target. Only then the new writes will take place. Now, in the case of synchronous remote replication, to optimize the replication process and to minimize the impact on application response time, the write is placed on cache of the two arrays. So, in case of synchronous remote replication, in order to optimize the replication process, means in order to reduce the response time, means receive the acknowledgement that the write operation have been completed, receive that acknowledgement quicker than usually. For that, in order to minimize the impact on application response time, the write will be placed, see this activity, the write will be placed on cache of the two arrays. That write operation will be placed on the cache of the first storage array as well as the cache of the second storage array where the target disk resides that stores the replica copy. Now the intelligent storage arrays destage these writes to the appropriate disks later. So where do you generally use cache? In intelligent storage systems, right? This we have understood from your second module where we studied about intelligent storage systems, right? Intelligent storage systems will have a temporary location called as cache where the data will be staged for temporary amount of time before it is written to a disk, so that if at all any data is being accessed frequently, the data can be staged at the cache itself so that the cache can serve the read request rather than consulting the physical disk each time. This will increase the I/O performance. This will reduce the response time of the physical disk. This will reduce the response time that is posed by the storage array. Right? So the intelligent storage arrays destage these writes that are staged on the cache. to the appropriate disk, means they'll be saved to the appropriate disk later. But initially, the data can be quickly copied on the cache and write acknowledgement can be given to the application server. Later point of time, this cache can be flushed out so that the data can be safely written to the disk at a later point of time. Now, if the network links fail, replication is suspended, if at all, where the network is being utilized to transfer the data between the cache and the disk, physical disks, or between cache and the storage array. If the network links fail, the replication activity will be suspended temporarily. However, production work can continue uninterrupted on the source storage array. So in such cases, when a network fails, the replication being taken at a target volume, that activity can be temporarily suspended, but still the data will be available along with the updations on the source disk, and that will be available to continue the business operations. Now, the array operating environment keeps track of the writes that are not transmitted to the remote storage array. So there is an operating environment available on the host side, available on the source disk's storage array. Means where the source disk is available, where the storage array has a source disk, where the original copy is saved, that storage array has an operating environment. So that operating environment will also be responsible to keep track of the writes that are not transmitted to the remote storage array yet because of network failure. Okay, so there is a mechanism to preserve the new updations that are made to the source data, and that is taken care by the array operating environment. Now, when the network links are restored, when the network is back to transfer the data, the accumulated data at the source disk side is transmitted to the remote storage array, and the replica is also made consistent with the source. Now, during the time of network link outage, if there is a failure at the source side, some data will be lost and the RPO at the target will not be 0. This is a small disadvantage because when the data is buffered at the source disk on the storage array, if the target disk fails, later when the target is restored, the data can be flushed onto the target. Or when a network fails and the network is restored back, then the buffer data can be shifted to the target. But in case of the source disk failure itself, in that case, some data may be lost. So the businesses have to afford for a minimal RPO in this kind of synchronous replication mode. Actually, synchronous replication promises near zero RPO, but in this case, in the case of a network failure, it can be avoided. Okay, so near zero RPO can't be promised in synchronous replication mode when the implementation is based on storage array remote replication. That you have to understand carefully. In synchronous replication, if it is host based, then immediately the data can be transferred. But if it is storage array based, the data is transmitted over IP network, and if the IP network fails, then up to some point of time the data may be lost. So that can be avoided. Now, this is how we can explain synchronous replication mode with a diagram. In this case, you can see the first operation. The production host will generate the write request. So, write from the production host is received by the source storage array. Source storage array means where the original copy of the data is being stored. Now, write is then transmitted to the remote storage array also immediately. Now, after that, remote storage array acknowledges that the data is written, means acknowledgement is sent to the source storage array by the remote storage array. Then source storage array signals write completion to the production host. Okay, so you can see here the production host and the source storage array resides on the source side, and the remote storage array where the replica is stored along with the remote host will be available at the remote site. So what does this remote host do? It also performs some activities like taking the backup or taking the archives. That kind of access can be shared by the remote storage array so that the source storage array will be available only for the application requirements. Now, what about asynchronous replication mode in case of storage array based remote replication implementation? Now, in array-based asynchronous remote replication mode, a write is committed to the source and immediately acknowledged to the host. This is what happens in any asynchronous replication activity, right? Whenever it is, irrespective of being it a host-based replication or a storage array-based replication, in both the cases, write is committed to the source and immediately acknowledgement is received by the host. Only then, after some point of time, after accumulating or buffering all the write operations at the source, it will flush it out onto the target site at frequent intervals. Okay, that is called as asynchronous replication. Now, data is buffered at the source and transmitted to the remote site later. Now, the source and the target devices do not contain identical data at all times. This is one of the drawbacks. As we have seen, the data updations will be buffered at the source, and at frequent intervals of time, it will be flushed out or saved, sent to the target, and the replica is saved. Now, in this case, when the data is buffered at the source and the source disk failure occurs on the storage array, in such cases, that buffer data will be lost. And also, after some changes have occurred and still they are not sent to the target, there will be difference between the source copy and the target copy up to some extent. Okay, that is what is mentioned in the third point here. The source and the target devices do not contain identical data at all times, like in case of synchronous replication mode, be it a host-based replication or be it a storage array-based replication. Now, the data on the target device is behind that of the source, so the RPO in this case is not zero. It may not be even near zero also. The RPO will be larger, recovery point objective will be larger, means the data that may be lost in case of a source disk failure due to buffering of the data before sending it to the host, before sending it to the target. So the data loss, the RPO will be up to the extent of the capacity of the buffer. Right? So how much ever is the capacity of the buffer, that much data will be accumulated before flushing it out. Now, when a source disk failure occurs at the storage array, then up to that amount of data that is held in the buffer will be lost. So that is called as the recovery point objective being same as the capacity of the buffer. Now, similar to synchronous replication, asynchronous replication writes are placed in cache on the two arrays and are later destaged to the appropriate disk. So, what is the similarity of this mode with synchronous replication? Asynchronous replication writes are placed in the cache here. In this case, when a cache is utilized, then we can reduce the loss of data up to some extent. How it can be done? Asynchronous replication writes are placed in the cache memory, the temporary storage space that is provided by the cache on the two arrays, on the source array, source storage array, as well as the target storage array, and are later destaged to the appropriate disks. So whenever there is a change that happens at the source cache, immediately that data, that change will be recorded on the target's cache also. Now, in case of a source failure, the cache also fails along with it, but the temporary storage cache available on the target side will have the updated data, and that can be committed to the disks, means that can committed to the replica on the target whenever the source fails, and can be restored at later point of time to the source once the source is up and running. This will avoid this RPO disadvantage, means it will reduce the RPO, it will reduce the recovery point objective, it will reduce the amount of data that may be lost due to the buffering that happens in asynchronous replication mode. Now, this is how asynchronous replication mode works. In this case, the production host, as a first step, the production host writes the data to the source storage array, and immediately the source array acknowledges the production host that the write operation is complete. And that data will be buffered at the source array side. Now, these writes are then transmitted to the target array, and after the writes are received by the target array, it sends acknowledgement to the source array. Okay, so there is a general approach that is being followed in synchronous and asynchronous replication modes. Whether it is a remote replication or a local replication, in synchronous replication, the data is ensured to be saved on the source as well as the target before write acknowledgement is received. But in asynchronous replication, first the source receives the data, immediately acknowledgement is sent to the application server, only then the data will be written to the target site or the remote site, and then acknowledgement is received from the remote site. Now, there is another type of storage array based replication, which is called as disk buffered replication mode. In disk buffered replication, it is a combination of local and remote replication technologies. Okay, so we have seen the goodness and drawbacks of local replication and goodness and drawbacks of remote replication also. Now, disk buffered replication mode is a combination of both the local and remote replication technologies. So a consistent point-in-time local replica of the source device is first created. So whenever this kind of replication mode is being implemented, when disk buffered replication mode is being implemented, then a consistent point-in-time local replica means whatever is the content available on the source, for that a snapshot, a point-in-time copy, a point-in-time replica is taken from the source device when first it is source device when the replication activity have to be implemented. Okay, so it is like taking a snapshot at one point of time. That is why it is called as point in time copy. So a consistent point in time local replica of the source device is first created. Then this is then replicated to a remote replica on the target array. So that point in copy is now transmitted over a network to the remote replica, and it is saved on the target storage array also. Now at the beginning of the cycle, means at the beginning of the replication cycle, the network links between two arrays are suspended and there is no transmission of the data. Initially, in the beginning of this activity, it means while implementing this disk buffered replication, then initially the network links, the IP network between the two arrays, the source array and the target array will be suspended, and there is no transmission of data that happens between source and the target. Now, while production application runs on the source device, means the application servers, as long as they are running, means accessing the source device, you have a source and a target, right? Generally, the source will be accessed by the application server or application host, and target will be accessed by the business continuity host. Right? Now, while the production application runs, this application host can also be called as production devices, devices or production applications. Now, while production application runs on the source device, a consistent point-in-time local replica of the source device is created. Okay, so it need not be made offline to take the replica. As during the application host accessing the source, at the same time, point-in-time replica can be taken from the source. Now, the network links are now enabled, means the connections are established, and data on the local replica in the source array transmits to its remote replica on the target array. So when this cycle starts, initially the network is cut between the source and target. Now a point in time copy is taken from the source and the network is now established, and that point in time copy is transmitted to the target site. Now, after synchronization of this pair, the point-in-time copy on the source device is being synchronized to the target. The network link is again suspended. and the next local replica of the source is created. So that is another what we say synchronized way of taking the replication. So each time a point in copy is being taken, the network connection is cut. Now, once the point-in-time copy is available, the network connection is established, that point-in copy is transmitted to the target. Now, once again, the network connection is cut and point-in-time copy is taken at the source, network connection is established, that point-in-time copy is transmitted to the target. This is what happens repeatedly as an initial step in disk buffered replication mode. Now, optionally, a local point-in-time replica of the remote device on the target array can be created. Sometimes you can also opt to take a point-in-time replica of the remote device and restore it back to source. That can also be done because business continuity hosts will try to access the target and they may make some changes on the target which may have to be reflected on the source device. In such cases, if you are sending the data from source to target, we call it as synchronization. And when the data is being transmitted from target to source, we call it as restore operation. These are all the terms that are used in business continuity lifecycle. So you should not be confused. If the source is being used to create the replica, it is called as synchronization. If the target replica is being used to update the source, then we call it as restore operation. And this can happen even in the absence of a disaster because that is part of the replication activity. Now, the frequency of this cycle of operations depends on the available link bandwidth and the data change rate on the source device. So, how much frequently the data is updated, that frequently this synchronization have to take place. Sorry, not synchronization, the point-in-time copy have to be transported. So, whenever change occurs, immediately a point-in copy is taken and it is transmitted to the target. But as long as there is no change in the source, you need not transmit it to the point-in-time copy need not be taken and it need not be transmitted to the target. Means you need not utilize the network bandwidth. So here the frequency of this cycle of operations means cutting the network, taking point-in copy, establishing the network, transmitting it to target. Again cutting the network, taking a point-in time copy when some updation occurs, establishing the network, transmitting it to the target. This cycle of operations depends on the available link bandwidth, how much bandwidth is available to perform this cycle of operations, and the data change rate. If the data is frequently changed, then the bandwidth utilization have to increase to frequently transport the point-in-time copy. But the data change rate is minimal, then you need not frequently transmit the point-in-time copies. Right? So this depends on these two parameters, the available link bandwidth and the data change rate on the source device. Because disk buffer technology uses local replication, why it is called as local replication? Because it is taking a point-in-time copy of the source data. Changes made to the source and its replica are possible to track easily. Okay? Because of this disk buffered implementation is using local replication, the changes that are made to the source and its replica can be easily tracked because every time a point-in-time copy is taken, it indicates that some change have happened to the source. That is how you can easily keep track of the sources, easily keep track of the changes that have been done to source and the replica. Therefore, all the resynchronization operations between the source and target can be done incrementally. That is why whenever resynchronization operations have to happen. Resynchronization means synchronizing the data that is changed on the source to the target where the replica is stored. So all the resynchronization operations between the source and the target can be done incrementally. Incrementally means you remember backup granularity. There we take incremental backups. So only when a change has happened, then only that change can be taken as a point-in-time copy and that change can be reflected on the target side rather than taking the entire data's point-in-time copy. That is called as resynchronization, which is done incrementally. Only with respect to the changes that are made to the source, that changes can be updated at the target. Now, when compared to synchronous and asynchronous replications, disk buffered remote replication requires less bandwidth. right? Because only when changes are made, a point in time copy is taken, and that too incrementally. Only the updations are taken, and that is transported to the target site or target disk. This, because of this, you're not transmitting too much of data over the network, so it will help us to save on the bandwidth. It will help us to reduce the bandwidth utilization. Now this is how disk buffered replication takes place. Now in this case, the production host writes data to the source device, and this in this case we can consider this as the source device, and on the same storage array you will also have a target device where the local replica is taken. Understand this carefully. When the production host writes data to the source device on the source storage array, immediately that updations will be taken as a local replica on the target device, but on the same site, but on the same storage array. Now, that is what is mentioned here. See, as a second step, a consistent point-in-time local replica of the source device is created on the target device, which is in the same storage array. Now, the data from the local replica in the source array is transmitted to its remote replica in the target array. That is the importance of this combination of local replication and remote replication. First, the local replica is created within the same storage array, and that local replica will then be transported over the network to the remote replica device, means to the remote volume, to the target volume at a remote site or a target storage array. Now, that is what is mentioned here. Data from the local replica in the storage array, this one, is transmitted to its remote replica in the target array, in the target storage array. Now, optionally, a local point-in-time replica of the remote device on the target array is created. Again, they are taking a local replica at the target site also, where the target site also will have a target device. In this case, this is called as the source, and this is called as the target at the target storage array. So when you take the data from the local replica of the source storage array and transmit it to the target disk on the target storage array, now at some frequent intervals of time, the target replica, for this target replica also, you will take a point in time copy that can be stored as local replica on the target storage array. So you are having two approaches being followed here. One is the local replica that is being taken on the source storage array and on the target storage array, and that replica that is taken is transmitted over the network from source storage array to the target storage array. That is transported through an IP network. This is called as remote replication. So disk buffered replication mode uses local replication mechanism as well as remote replication mechanism, which will help us to reduce the RPO, means which will help us to reduce the recovery point objective. That is the amount of data that can be lost due to failures of storage arrays or data centers. Now there is the last type of technology that is used for remote replication, that is network-based remote replication. In network-based remote replication, the replication occurs at the network layer between host and the storage array. Same thing happens in local replication also. So what are the two layers that are responsible for performing this network-based remote replication? The host and the network layer between the host and the storage array. So you have understood from the previous sessions that on the host side, you will have a stack of protocol layers. And on the network side, on the storage array side also, you will have some layers of protocols that will be executed during communication between two endpoints, right? So this will have the application layer on the top, followed by various other layers, network layer, communication layer, ISCSA protocol layer. Okay, so for every node that is involved in the communication over the network, that node will have some layers that will perform, that will enable the, or that will facilitate the communication between the nodes. Now, when it is a network-based remote replication that is being implemented, then the replication occurs at the, say here we have a network layer. And on this side, on the storage array side also, you'll have the network layer. So this network layer between the host and the storage array will take care of the replication activity. In host-based remote replication, host will take care of the replication activity. In storage array-based remote replication, storage array will take care of the replication activities. But in network-based remote replication, the network layer, which is on the host side as well as the storage array side, that will take up the responsibility of performing this remote replication activity. Now there is a concept called as data protection. Okay, continuous data protection. Continuous data protection, how is it promised using a remote replication, that we are going to see now. In normal operation, continuous data protection means CDP remote replication provides, means continuous data protection by remote replication provides any point in time recovery capability which enables the target LUNs to be rolled back to any previous point in time. So how is this continuous data protection ensured by remote replication? In normal activities, generally, this CDP remote replication provides any point in time recovery capability. Any point in time recovery capability will make the RPO 0. Means there is no risk of losing even a fraction of data. Any point in time, the recovery is able to be performed, which enables the target LUNs. So how is this any point in time recovery enabled? By enabling the target logical unit numbers to be rolled back to any previous point in time, to roll back to the previous checkpoint so that no data will be lost. Now, similar to continuous data protection local replication, CDP remote replication typically uses a journal volume. I think it should ring the bell for you that we have learned about this journal volume in the first chapter, journaling, file system journaling, right? So journaling is again a temporary file where the data changes will be stored. So CDP remote replication typically uses a journal volume, continuous data protection appliance. So this uses the mechanism of journal volume CDP appliance. There is an appliance called as journal volume CDP appliance or CDP software installed on a separate host, which is a host based, which is called as host based continuous data protection, and a write splitter to perform replication between sites. So this, in order to implement this continuous data protection remote replication, it has two entities. One is the journal volume CDP appliance, and the other one is the write splitter, which will perform the replication between the source site and the target site. So the CDP appliance is maintained at both source and the remote sites so that if any disaster or failure occurs at one of the sites, still the data can be rolled back to any point in time to get the recovery of the data, to recover the data. Okay, this is called as CDP remote replication. Now in this step, in this method, the replica is synchronized with the source and then replication process starts. So as an initial step in any of these replication methodologies, initially the source is synced with the target, means the target copy, the replica is made consistent with the source as an initial step. Then the actual replication process will start whenever some change happens to the source. Now, after the replication starts, all the writes from the host to the source are split into two copies. Understand this carefully. This is another important question. How continuous data protection is ensured by remote replication? Now, initially, when the source is synchronized with the target, as a next step, what will happen? All the writes from the host that are performed at the source are split into two copies. Now, one of the copies is sent to the local CDP appliance at the source site, and the other copy is sent to the production volume. Okay, so where the local appliance, where the local CDP appliance is available on the source side, one of the write updation, that copy is sent to the local CDP appliance and the other copy is sent to the production volume. Now, after receiving the write, the appliance at the source side sends it to the appliance at the remote side. So though production host saves it on the source disk, then there is another copy available, right? So that copy, the appliance, the CDP, the local CDP appliance will at the source side that is available, which has the copy of the new write, will send that copy to the appliance, CDP appliance that is available on the remote side. Okay, then the write is applied to the journal volume at the remote site. So on the remote site, one journal volume will be maintained. So that write that is sent by the local CDP appliance to the remote CDP appliance, first it will be written to the journal volume at that remote site. Now for an asynchronous operation, this is how synchronous operation is performed. Now in asynchronous operation, writes at the source CDP appliance are accumulated every time. In asynchronous operation, the data or changes will be buffered. Only then they are flushed to this target site. So for an asynchronous operation, writes at the source continuous data protection appliance, it has a source CDP appliance, right, at the source site. They are accumulated, the changes are accumulated, and redundant blocks are eliminated. So the changes are accumulated there, and if at all the changes are being overwritten, then old changes will be removed. So redundant blocks are eliminated. So multiple writes doesn't happen, same kind of writes doesn't happen again and again. Then the writes are sequenced and stored with their corresponding timestamp. That is very important, because in what order the write operation happens on the source, they should be replayed at the target site in the same order. Otherwise, there will be inconsistency in the data. So the writes are sequenced at the source site with their corresponding timestamp, in what order they are executed, in what order the writes have been executed. In the same order, according to the timestamp, they are sequenced. Now the data is then compressed and the checksum is generated. Now, rather than passing all the data together, the writes are compressed and then a checksum, a parity kind of data, a checksum will be generated at the source site. It is then scheduled for delivery across the IP or FC network to the remote CDP appliance. Now, this checksum, rather than passing the entire write operations, as I said, they are compressing the write operations, generating a checksum or a parity, and that will be transferred to the remote CDP appliance through an IP network or an FC network. Now, after the data is received, the remote appliance verifies the checksum in order to recalculate the original operations to ensure the integrity of the data, so that whatever the replica is being maintained, the data should be consistent with the source, right? In order to ensure that it verifies the checksum, and then the data is compressed and written to the remote journal volume. So on the remote site, the CDP appliance will have a journal volume associated with it, right? So the data is compressed, the data is uncompressed or unzipped after the checksum is verified to preserve the consistency, and that data is written to the remote journal volume. Now, as a next step, data from the journal volume is sent to the replica at predefined intervals. So data from the journal volume, data will be recorded at a temporary file called as journal volume at the remote site, right? So that is sent to the replica target. Replica means the copy which is residing on the target disk on a remote site, right? So as a next step, once the data is received by the CDP, remote CDP appliance, it will find the checksum, it will verify the checksum to ensure the integrity or consistency of the data. Then the data is uncompressed. First, it is written to the remote journal volume. Then, as a next step, it will be written to the target disk where the replica copy is saved. Means the updations will be replayed against the target disk. So this is how it happens here on the source. All the write operations, write operation 1, write operation 2, write operation 3, they are consolidated and a checksum is calculated. a parity bit or a checksum is calculated. Now that is transmitted to the remote site, and on the remote site, you will have again a CDP appliance, continuous data protection appliance on the remote site. So that will receive the checksum and it will verify whether the checksum is is preserving the integrity, means it will recalculate the checksum to get the data back. Now it will see whether it is consistent with the original file or not. Now after the checksum is verified, it will uncompress the data and that data will be returned to the journal volume on the CDP appliance site at a remote site. Now this journal volume at frequent intervals, it will save on the target device where the replica is available. It will update the replica copy that is available on the target device. Okay, this is how CDP remote replication is performed, and that is explained with this figure more clearly. Now the production volume where the source storage array resides. Now sorry, this is the source where the original copy resides. That is also called as production volume. Now you will have an application host which will actually generate the write operations. Now when the write operations are generated by the host, it will send two copies, one copy to the production host to be saved at the source storage array, means it will save the original copy on the source side, and another copy is given to the write splitter. Now this write splitter sends that copy over SAN or IP network to a local CDP appliance, and this local CDP appliance will further transmit over a SAN or WAN to the remote CDP appliance. Now this remote CDP appliance further verifies the checksum that is passed by the local CDP appliance and checks for the consistency of the data, and after the consistency is checked, it will uncompress the data to write the data to the CDP journal first. So the data is written to the CDP journal first, where it is temporarily stored, and at frequent intervals of time, it will be sent to the replica, that is the target where the replica is stored, so that all the changes that are recorded in the CDP journal will be updated on the replica copy. Now, after this much of process, this target will be consistent with the source data. Okay, this replica will be consistent with the source only after completion of all this process. So all this CDP journaling and updating the replica, that happens on the remote storage array or at a remote site where the target disk resides. Okay, this is how CDP remote replication is performed. In the asynchronous mode, the local CDP appliance instantly acknowledges a write as soon as it is received. This is another advantage of continuous data protection remote replication. What happens in asynchronous mode? The local CDP appliance that is available on the source side instantly acknowledges a write as soon as it is received. As soon as it is received by the local CDP appliance, immediately it will acknowledge the host saying that the write operation is complete. In the synchronous replication mode, the host application waits for an acknowledgement from the CDP appliance at the remote site before initiating the next write. This is what happens always, right? In asynchronous mode, local CDP appliance or local host, or source device itself will acknowledge the host that the write operation is complete. But in synchronous replication, first the local or the local CDP appliance or the source device will perform the write operation. Then it forwards the write operation to the target device, or in this case, remote CDP appliance, and only when it is journaled and that journal is saved on the replica copy and the replica copy is made consistent with the source copy, only then the data will be, that write complete acknowledgement will be received by the application host. That is called as synchronous replication mode. So the underlying idea in synchronous and asynchronous replication modes is the same, whatever is the technology that is implemented. whether it is a host-based replication or whether it is a storage array-based replication, or whether it is a network-based replication, or whether it is a continuous data protection promised by remote replication, whatever is the implementation in asynchronous mode, the acknowledgement is received immediately, but in synchronous replication, the acknowledgement is received only when the replica copy is updated. Now, the synchronous replication mode impacts the application performance under heavy write loads. So, if the application is write intensive, if more number of write workloads are being posed at the source site, then that will this kind of synchronous replication will impact the application performance. It will increase the response time because the application has to wait until it is written to the local CDP appliance and then to the remote CDP appliance, journal it, write it to the replica, only then the acknowledgement is received by the application host. That is why the response time is large in case of synchronous replication, but it provides near zero RPO. But asynchronous mode, the response time is, though the response time is less, it will not promise near zero RPO. There is always danger of losing some amount of data because of the large RPO that is encountered in asynchronous mode. Okay, this is how we complete our syllabus with our 5th module. Do you have any doubts, students? Leave out the doubts. If you are regular to the class itself, I should be happy, I think. Okay, I'll stop the recording and take attendance.